No, I've talked with them and I feel like.
Very delicious. All right, it looks so different.
Calculated a risk reward.
I reserved it for us. Or well, I put my water bottle. It's for us.
I actually read Khalifa's book called Make It. It's like the history of how.
Someone who wants to talk to me? Someone said my name.
Not yet.
Hello. Was it you who said my name? Someone did. Or were they talking about Apple Cat?
I don't know. I didn't take your name in vain, though.
We started watching
Did you hear someone talk?
Like 5 seconds ago.
Oh, no, I've been talking to someone else. So don't
more appropriately dressed for this room. Anyway.
It's so funny. I want to die.
So that'll be a while. I had to do it all.
Hello.
Are there more batteries? Oh, they're here. Okay. We're good. We're good. We're okay. Someone must have changed it between noon and right now. So. This has 2 hours. Now for all of these presentations.
Those batteries and those clickers will usually last.
Okay.
You can't move anywhere else but
But we want to say we don't watch it that much.
every year.
Yeah.
Every month they centers. A lot of other times.
I don't need it. Word to capture you. Be careful now. Okay. Good afternoon. Yeah, are there any slides here? I think slides are coming. They're not here yet.
4 of course plan is here.
Oh, they are? Oh, hey! All right, so we got to find some room. So, we're at final presentations. For those of you who've never seen final presentation, every team's going to have 15 minutes to give us a sense of what they've accomplished this semester. So we have 4 teams going today. After 15 minutes, producers keep an eye on me for time. Then 5 minutes Q&A, and then we'll move on to the next team. So, like I said, 4 teams. We're starting with Wandermath. We're ready to go. Then we do Lyraflow. Then I can't read my handwriting. Ideal, and then we'll end with 404 production. So, Wandermath, take it away.
Hi, everybody. We are Team Wandermath. I'm Kat, the one of 2 co-producers and the designer on the team.
I'm Sophia. I'm the artist.
I'm Leslie, the other co-producer.
I'm Jacob, one of the programmers.
I'm Yanqing, another programmer.
And Mike and Tom are our faculty instructors. Our client, Luke Harris, is the director for the Center of Arts and Education at West Liberty University. She provided us with reference material based on MathWalks, an outdoor math tool invented by math teacher Tracy Jackson, which allows students to explore math in the low-anxiety environment of an outdoor walk on the sidewalk. In a math walk, students are exploring an environment with a variety of math activities. Our task this semester was to translate the key components of MathWalks into the augmented reality space. Therefore, our goals for our deliverable were set at the beginning of the semester as transformational content accuracy, playtesting, and gameplay and interactivity. And our final app managed to accomplish these. The playtesting feedback showed that the students were engaged with the content and with our character Finley, and we're able to give them a chance to practice a math concept that they had not yet mastered at their level.
Inspired by math walks, we want to keep the math buffet ideas in our Wandermath project. So we create 3 AR activities, have a main menu to offer the buffet to teachers and students, giving them freedom to choose the activity, walk around, and play. The 3 activities are birthday party, skate park, and carnival, covering 4th and 5th grade geometry concepts such as folding the nets of 3D shapes, calculating the volume of prisms, and graphing points on the coordinate plane. We'll walk you through these 3 activities in more details later. Moreover, it's already on App Store and Google Play Store, so teachers and students can download and play it anytime, anywhere. You can try it out too.
To begin breaking down our final deliverable, we'll reintroduce you to our resident skateboarding chinchilla, Finley. They have received very positive feedback from our playtesters, and Finley's guidance and animated feedback motivates our students to complete each math activity. Finley was the largest asset we had to work on this semester, and these images are a more in-depth breakdown from the character rig process, from initial concept to a working rig. With all 3 of our math activities reaching our minimum viable product, these are the final animations that went into each one. We wanted the animations to be very expressive and stylized, and Finley was animated at 12 frames per second to achieve that stylized feel. One of the biggest challenges with Finley was making the rig feel good in AR. While Finley was animated to look up at the guest in Maya, we also had to take into account different heights of the students and moving tablets. In one case, we overrode some of the animation in the joints to make Finley connect more to the player by constantly looking up at them. On the rigging side, Finley presented new obstacles in terms of creating a clean, single hierarchy rig with props and blend shapes that worked well in Unity. As Leslie mentioned previously, we created 3 distinct math activities for our final deliverable. Our first activity, the birthday party, went through a lot of iteration between the start of the semester and where we are now. It is our first prototype in AR, and we learned a lot about the limitations of our tablets and gameplay from it. The main mechanic is simple. Help Finley fold a series of flat net shapes into 3D objects. The difficulty of each foldable object increased in each level as the students were introduced to more and more complex shapes. We also realized that having Finley simply talk about a birthday party was not enough for our playtesters. We needed a bigger reward for them to complete the activity. Therefore, we added a short cutscene with Finley skating into a chinchilla birthday party.
So after the birthday party, we wondered if there's anything else we can do with Finley and his skatepark. So we landed on Skatepark, which focused on the concept of volume. So in phase 0, we started the activity with 2 dots and teach users the basic mechanism of drawing lines accurately in the AR world. In phase 1, we provide users with 4 dots to let them draw a 1 foot by 1 foot box, explaining the area of 1 square foot. We then allow them to lift it up to form a cube by dragging, to show them the concept of 1 cubic foot in volume. In phase 2, we increase the difficulty by giving them 6 dots, where they are allowed to draw a bigger box with larger area. The user must then lift it up with any side of the box to form a ramp to be used for skating. So in the last phase, we gave the users a 4x4, 16 dots to create anything they want in the skatepark. Here's a short demo video.
There's also 6 cubic feet of extra concrete to make more obstacles. Connect dots to make rectangles. Then, drag up the middle to make a ledge, or the edge to make a ramp. Woohoo! Totally rad!
That's the short demo we have. So in order to reward the users to stay engaged throughout the activity, we have added various forms of skating animation or Finley for each phase, like skating on the railing or jumping over the cube to add excitement and fun for the users. We have also added skating animation on the ramp, as what you can see previously. So aside from the tedious process of testing, the biggest challenge we face is objects drifting in the AR world. As you can see in the GIF, Finley and the cube is constantly moving by itself without any logic. This issue exists for every activity, but is especially more evident in the skate park activity as we require accurate measurements of each action. As a result, we came up with a solution to use AR anchor, which helps in mapping of the locations in the real world. This elevated the problem, but it is not enough for accurate measurements still. Hence, we decided to constantly keep track of objects in the AR world and update the locations and statuses of these objects to ensure that the measurements and locations are accurately used. So after utilizing Finley's skateboard, we wonder how we can create an experience that makes users feel like we are rewarding them with something. Hence, we came up with a water balloon carnival activity, focusing on the coordinate plane math concept, with Finley packing all the gifts for the user. So in phase 0 and phase 1, we started at the activity with simply the X coordinate and the Y coordinate, while teaching them the basic mechanics of moving the cannon. In phase 2, we increased the difficulty by giving them both X and Y coordinates, where they need to follow the ordered path provided to hit the target shown. So in the last phase, we further increased the difficulty by giving them coordinates to find where the prizes are. So here's a short demo video of it.
The order of the paragon switch. The first number is the x-axis, and the second number is the y-axis. Wow, you did amazing! You got all the prizes. Let me just pack these up for you. All right, thanks for coming to my carnival. See you later. Another component of our deliverable is to help the experience run smoothly in the classroom. So we created a teacher resource guide inspired by the work of previous ETC project PRISM. Our teacher resource guide was developed through conversations with West Liberty University education professors and students, as well as teachers who visited the ETC through Remake Learning. We were able to test discussion questions with real students who playtested the app itself. Our resource guide includes a detailed walkthrough of each activity from the student's user journey perspective, with screenshots to help the reader follow along. Every step of the way, we've also included information about the math concepts covered by that portion of the activity, and some questions teachers can ask their students about what they're exploring. One section that was very important to teachers is mentioning what's not covered in the activity. For example, the carnival doesn't include fraction, decimal, or any negative numbers in its coordinate plane. This way, teachers can make an informed decision about where to fit Wandermath into their curriculum. In order to fulfill our goal of creating an experience with open-ended discussion, we included several prompts teachers can use to give kids a chance to think about the math concepts. For example, after the skate park, a teacher could ask the student how they know how much concrete was being used as a jumping off point to talk further in depth about the volume formula. Our original idea was for all questions to come at the end of an activity, but we also decided to include some that a teacher could ask in between different phases within an activity, if that's how they prefer to structure their class. For example, in the skate park, students can predict whether the ledge or ramp would use more concrete before they start, and once they've built both, discuss their predictions. Finally, we have detailed tech instructions and troubleshooting FAQs for each activity, as well as Wandermath as a whole. One of the most beneficial things to our project was frequently playtesting, and we ended up with over 70 people. We started the semester playtesting at 2 Children's Museum of Pittsburgh locations, but after halves, we were able to playtest at ETC Playtest Day and Bell Vernon Middle School, both with young teens, and at the ETC with a proxy audience of teachers, all in an attempt to get closer and closer to our demographic and focus on transformational accuracy. But most recently, we were able to playtest the whole experience with 13 students in our exact demographic of 4th and 5th graders who attend elementary schools that partner with West Liberty.
Yeah, we get a lot of valuable feedback from the playtests. First of all, we realized that we should pay more attention to our target audience. We found students like paying more attention to Finley than our interactable objects. They would miss the object entirely because sometimes they just want to be closer to Finley, and even like we're sitting on the floor, we're playing the game. So to solve that, we made the interactable object initialize right next to Finley. Another takeaway from the playtesting is called developer bias. When we testing the project internally, we wanted to play every single phases in the most correct way, but our player doesn't know everything. For example, when building the ramp, we first provided the total audio to help players understand where to lift, but it wasn't clear enough. So we added outline for the ramp and highlighted each edge to make it more user-friendly. We also get a chance to relearn a very important game design concept by the playtesting, the indirect control. During the gameplay of the third activity, player will move the canoe by moving up and down and left and right to hit the targets, and then XY coordinates. To ensure that all the players fully understand how to control the canoe, we have a total audio, UI indicator, and even sound effect. But we actually forgot to simply put 2 handles on the canoe, which is even reminded by our playtesters. So we learned that the visual designing can be a very important part of the guiding the players throughout the whole gameplay.
From a design perspective, our biggest lesson was to be specific about our use case early on. But at first, we thought 1 student per tablet would be best, but we found that students had richer mass discussion when in pairs or groups of 3. Luckily, our design was flexible for both. From production perspective, we learned a lot how to use different methods or tools in different phases of the project. We use Trello to manage tasks for the most of our semester. However, it's easy to miss something without a clear view of what assets need to be used in which part of the activity. So we started to create flowcharts for Skatepark and Carnival. Moreover, when it came to week 11 and 12, the most important task for us is finding what can be improved and prioritizing them. So we start to use a shared Google Doc to record the progress and do a simple version control for everyone. Looking back to the whole semester, one thing we need to improve on is that we need to not only focusing on qualitative data, but also looking more into the quantitative data so that we could better show our outcome to you. But one thing is certain, kids love Wandermath. All in all, our team had a fruitful semester, and we want to give our special thanks to everyone who helped us along the way. In particular, all the teachers and students who gave us their time and expertise. In conclusion, we are Wandermath, providing 4th and 5th graders a math buffet with 3 activities, helping them see math and play with math through AR technology. Now we are open for questions.
Yeah, go ahead, Bob.
So when you're drawing the geometry, volumetric, is the 1 feet scale real world to 1 feet?
Yes, that's correct. Yeah, so the question for the stream and everyone is whether the measurements in our skate park activity are accurate to real world 1 foot measurements, and they are. Ricardo?
You guys seem to have done a lot of thinking about. Can I have a mic? You guys seem to have done a lot of thinking.
Just press it once. That's it.
Okay, thanks. Yeah, you guys have done a lot of thinking about the teacher using this in the app and outside of the app. Did you guys come across any tips or best practices for arranging the classroom so that when they're using the app, it actually looks better, responds better, anything like that?
Yeah, so the question is about different ways of arranging the classroom that might work better with the app. Just to clarify, do you mean like physically arranging the space and desks and floors and things like that? Yeah, so that's a really good question that we didn't have a lot of clarity on early on in the semester because every teacher that we talked to has a completely different setup. Some of them are flexible and some of them are not, just depending on how much furniture they have in the classroom and, you know, the type of funding situation their school has. So we wanted to create activities that both require a small amount of floor space, such as the carnival. All it requires is just a little area to initialize right in front of you. And then the skate park requires 4 feet by 3 feet in front of you to be able to do the sandbox portion. So yeah, we wanted to be flexible because the classrooms aren't always flexible. Yeah, another from Bob?
Okay, so the app is already on the Play Store and Apple Store. Is it called Wandermath? Because I can't find it on my store.
Are you looking in the Apple Store or the Play Store?
Google Play Store.
Yeah, so maybe I can take that. So it's only open for US. So if your account is not in US registered, you wouldn't be able to find it. I have this issue as well. So we are planning to open to more countries, but at least it's out for now for the US.
Okay. Is it free on the App Store?
Yeah, absolutely. Time for one more? All right, thank you, T.
All right. Good. All right. Hello, everyone, and thank you so much for being here today. We are Lyraflow, and Lyraflow is a discovery project exploring how interactive visualizations in VR can facilitate engagement with music theory and increase accessibility for interested university students. Our team is composed of Wizard Hugh, programmer, Noah Kenkanala, producer and sound designer, Wish Ko, programmer, Yuji Sato, assistant producer and sound designer, and Jack Wesson, artist and designer. Our faculty advisors are John Desler and Ricardo Washington. It's important to clarify that throughout the semester, we've been running and operating as a discovery project rather than a teaching tool. We have been focusing on exploring and finding methods rather than creating polished deliverables. This is because throughout our research, we found that the crossroads between music theory and VR is quite novel. Throughout the semester, we've been functioning as an R&D team and leveraging prototype design as a vehicle to find out what works and what doesn't. So to summarize, we've been focusing on finding VR and music theory synergy. We have a short teaser demonstrating what we have been up to most recently. So in that experience, Jack was learning about major and minor, and that was our third prototype, and we'll talk about that in a little bit. But first, at the experience or prototype level, we've been driven by the goal of fostering musical curiosity and enabling the guests to ask better musical questions. And we define musical curiosity as a self-driven exploration, pursuit, or reflection of music. We define a musical question as a notion along the lines of, why does this piece of music sound and feel this way? So regarding the user journey, we aim to introduce our guests to a particular musical topic and give them the environment, the space, and the room to play, experiment, and listen. Then, when they emerge from the experience and they're out in the reality, say they're at the play or they're at the cinema, they hear a piece of music and they say, you know what, I think this is minor. Or they're at the orchestra and they hear a piece of triumphant orchestra crescendo and they're like, this is major. These are the things, the sentiments that we hope to capture in the post-experience. So next, Yuji will talk about the first half of the semester and some of the learnings that we found.
Great, thanks Noah. So in the first half of the semester, we made 2 prototypes, the harpoon and the accordion. And we quickly realized that we had to make some adjustments going forward. First, we had to kind of tone down the number of concepts we were tackling because we had so many concepts, we were confusing and distracting our guests. Second, we had unclarity about musical curiosity. What does musical curiosity mean? What does fostering musical curiosity actually look like? These are questions we had to answer going forward. And lastly, we had to also take into account the great feedback we got from halves, such as our prototypes had a limited ability to allow re-listening to the audio, which made it hard for players to pick up subtle audio clues. There were too many interactions that were both overwhelming and distracting. And lastly, our slow feedback loops made it so guests were never quite sure if they were doing something right or wrong. So taking these things into account, we moved into our third prototype, where we tackled one topic, tonality, specifically major and minor. And we chose this concept because it's a binary concept that's easy to compare and contrast. And for success, we tried to define it more clearly, as the guests will be able to hear the differences between major and minor after our prototype. And for musical curiosity, the guests will be willing to ask questions like, oh, was that major or was that minor, when listening to music in films, games, etc. And for VR usage, we shifted from focusing on interactions to seeing how VR could help us direct the focus and attention of the guest to the concepts that we want to convey. So we first began by paper prototyping to see how people perceived major and minor. We did this by making a musical theme and creating variations of it. A major variation, a minor variation, and a mixed variation of major and minor. Without revealing what variation was what, we had playtesters listen to it, and we gave them a collage of images. And we kind of just explored how people would match images to certain variations. And after 36 playtesters, we had enough data to kind of get a good idea of what kind of visual associations were made with each tonality. And going off of this, we did one final test where we took the 3 top images and sent it out to playtesters to see how they would match it to the music. And out of 20 testers, 18 answered the way we expected, so we were pretty confident about where we were going. And we first just transitioned to VR and made a very low-cost prototype, which was pretty much a 3D version of our paper prototype in VR, and it still worked. So now we transitioned to a full VR prototype, which would have 3 stages: exposure, exploration, and application. And now Wizard will talk about the first stage, exposure.
Thank you, Yuji. So the first stage in our world is the exploration stage. So when the player enters the world, a guest could see 3 pictures in front of them and hear the music. And then, based on how they perceive the music, they can choose the image that matches the music. And after finish their selections, they can experience the music in the 360-degree version or image they choose before. And at that time, they also can switch between major and minors and modify surrounding based on their feeling to this music. In this experience, there's no correct answer for this, so they can do what they like to do. The goal of this stage is we like to allow the guests to listen to the audio and get a simple and initial glimpse into the concept of major and minor. To reach this goal, we limit the complexity and the number of VR interactions in this stage. For example, when the guests enter our world, we use the simple clicking button interactions to let a novice guest who is not familiar with VR. Also, we utilize the black surroundings to allow the guests can pay attention and listen to the music. In the early version of exposure stage, we try to use the gas detection mechanism. That means we detect which image the guest is watching at, and then we will play the specific music. We think that rotating head is a simple interaction for live guest. But after playtesting, we find that when live guests step into the VR world, they tend to watch around the VR world. So the music will keep changing, and it will distract them from listening to the music. So we switch the mode in simple and natural interface. The simple slide for switch between the major and minor, and also put the serious image beside it to allow the guests know that they can change the surrounding based on selecting the music. We also utilize the VR that add in a panoramic environment and add the visual particle system to enhance the immersions. For example, lake with maple leaf, and desert with sand, and forest with firefly. We want to improve the conveyance of major and minor to the guest. After the guest is good for their matching, they can press the finish button to the next stage, exploration stage. And now, I will pass to Jack to talk about that.
Thank you, Wizard. Yeah, so I will talk to you guys about the exploration stage. And just to kind of go over this, the goal of it was to listen to those variations of a single score, which we were just changing that one thing, to see the accompanying visual feedback that went with that change, and then together that would reinforce the modal understanding. And so the biggest part of this was the experience flow, to make sure that people are actually understanding this. And we iterated on this a ton, but this is the final setup that we did have, where you can see the lights that you control for each section, the dials, and all of them had a mixed or minor or major valence to them that would actually go along with that. And so just to kind of show what that looks like. Note that we added some story elements to give it a narrative. So that's the gist. And the water level is changing, different things are changing, but the lighting was the key. And notice the slow change. So we actually iterated heavily to get to these things. We originally thought there would be a door to add in a little bit of control to the user to enter the scene, but we didn't want to overshadow the musical concepts. People liked it too much. We had a roller coaster that went through it. We actually flirted with a ton of different mechanics. One was a camera that would allow people to stage shots and be more creative. We even accidentally stumbled into some deliverables that would be great, like a Dungeon Master's toolkit that would allow the game master to switch between diegetic desert music from major to minor when the members of their party encountered danger. And so we ran DM sessions as one of our prototypes as well to kind of explore that further. And so we had a lot of different product ideas. One that was actually really successful was genre, and Wish will tell you more about that later, where we had genre going to 8-bit, and the people could hear the differences in different genres of music and kind of piece everything together even more. And we think there's probably even more possibilities even beyond this, but there's more duration out there. The interface itself was really important to iterate on. We had these joysticks that were controlling individual notes because we thought it was so cool that only 2 notes were changing between major and minor. Too confusing, too granular. We needed something more gestalt, which we got this kind of slider that would change the lighting overall. That worked. We actually simplified the slider. We made 3 of them and had a linear flow across the table. That's why you saw those 3 sections. And then we kind of landed slightly differently because the slider didn't let you go from major to minor, and that was the most dramatic change. And you'll hear that in the next piece. But it goes now major to minor in this dial. This wheel actually connects all the way around. And just kind of reiterating, this took us a long time. We had about 90-ish scenes of just totally new prototypes, even in this one section, just to give you a sense. And you know, it was just a lot of experimentation. There's a lot of avenues, but we are a discovery project. This is the middle section. The sandstorm, those heat waves were very nauseating in the roller coaster, trust me. So that's the gist of this one. And then the final one we had, this sort of like palace section here. And that was the visual feedback. And just note that the light changes slowly and everything kind of fades in. That was really important because people thought that the music was being changed as a result of how they were switching the scene, but the art kind of had to fade in slowly. And that was one of our discoveries, that the art kind of had to come in to look like it was responding to the music. And that's kind of our final setup, just to reiterate. And I'm going to pass over to Wish to talk about the application of these.
Thanks, Jack. So after our exploration, we introduced our application stage for guests. We offer them the opportunity to apply what they have learned about major and minor so far. And we minimize the visuals once again to help them to be more focused on the audio itself. The application stage was designed to be an interactive story where the guests can change the outcomes of various scenarios by adjusting the music to major or minor. And here is a demo. So after a short content, the guest will be able to switch the music to fit that narrative. And the story will switch to different branches according to their choice. And even if they end up with bad end, don't worry, we will bring them back. So at this time, they can make another choice. And in this stage, we even change our interactive process. Instead of revealing the result immediately, in this stage, we ask them to pick a choice first, and then we show the result. And during the playtest day, we got 26 playtesters, and 90 of them were familiar with major and minor. And 23 playtesters can find the difference between major and minor. Many of them agreed that they can tell the connection between visuals and sounds. And they also mentioned that they will be more aware of the music in their daily life, which is great. Based on the feedback of our playtesters, one future work could be done is to offer music in different genres. For example, like country, jazz, or pop music. By offering different genres of music, we hope the guests could recognize major and minor easier, because they could find the genre that they are more familiar with. Next, I'll pass to Noah to explain our discovery.
Thank you so much, Wish. So zooming out and looking at the semester as a whole, we have learned many valuable lessons throughout our journey, exploring and highlighting the possibility of this space. And these discovery findings can be categorized into two groups or categories. This is transformational design and musical conveyance design. So at the transformational level, we learn the power of binary choice, giving the guests the ability to compare and contrast variables. We additionally learn the importance of scaffolding. How can we properly introduce onboard guests into experience and properly exit them, allow them to emerge from the experience with a pinnacle of knowledge or something like that. Additionally, we learn the power of exploring a high-level concept and using that as a gateway so guests can learn about a particular concept. Additionally, we learn about the power of abstraction, using the metaphor and personification as a way to make complex concepts a little bit more easy to understand. Relating to music, we learned about the power of using emphatic repetition and auditioning, giving the guests the control to listen to the music as much as they want at their own pace. And we found that guests, it's hard for us to take the time to sit back and listen. We're motivated by visuals, and we learned to put the music first by limiting interactivity and also giving the guests the breathing room to listen at their own accord, at their own pace. So as our journey comes to an end, we believe that we have learned so much in this space, and there's so much possibility, and we've only explored a fraction of it, and we hope and we urge that there's more work out there. So thank you so much. We're very proud of our work, and we're very appreciative of the opportunity we were given to explore this space. And just to summarize, Learflow, we have been exploring the crossroads between VR and music theory. Thank you so much, and we're now open for questions.
Yes, Chris.
I have about 50 questions. I only have one. If you wanted me to focus on music, why did you add interactive storytelling?
So the question was, if we wanted people to focus on music, why did we add interactive storytelling? And so to answer that, I think one of the biggest parts of this was giving people structure first and then taking it away. And the interactive story was really useful in providing the structure so that people felt comfortable instead of just free-form exploring with no agenda. The story gave them something to strive for. And then at the end, when we finally put a literal story out there, that gave them a chance to try out the story and play a musical piece, think about what it was going to do once they had made their expectation, and then have that either confirmed or rejected based on the music. So we kind of wanted to start like low, add in a lot of stuff so people felt more and more comfortable, and then strip it down again so that they could experiment and see what they had done. Any other questions? Mike?
So looking back on what you did and what you could have done, is there consensus among the team that, oh, we should have maybe let this one alone and tried this instead?
Definitely. I think the approach we took in the second half of the semester was much more effective at inspiring musical curiosity and appreciation. I think the first half of the semester we focused too much on interactions and granular details. That's probably fit more for like direct teaching or musical learning. And that was we definitely shift courses, mainly because as we prototype more on VR, we found that the strengths of VR is more of like providing an environment that we can control so that we can help people focus on the thing that we're trying to try to convey, instead of like making granular details. Like reading and writing is very difficult in VR, and that just we found that reading and writing is pretty crucial for teaching advanced music theory concepts. So yes, our pivot after halves is very helpful for us.
Do I have one more?
Mo?
Of the three minor major explorations, that sequence of three, which is the most effective and why?
Definitely the middle one, I would say. And mainly because we tested that one the most. Sorry, the question was, what was the most effective of the three variations? That one really, it feels a very specific way to a lot of people. That one people really latched into. And it was the inspiration for the rest of them. So the others are also really good. I don't think there's any one best one, but that one really seemed to do the job well. Do you want to add to that, Yuji?
Sure. Well, I do think the second one was most successful at inspiring musical curiosity. However, I do think that the first step is crucial in that it's the place where people have less visuals, and the it is more successful, right? But I would say the second one is not perfectly successful because there's too much information visually, and people who are new to this concept aren't able to focus on the audio, which we found, which is why we created the onboarding or the exposure stage, so that we would provide a safe place for like new people to come in, where they could just focus on the audio, hear the little differences, and then they can go to this place with more cool visuals that would really inspire the musical curiosity.
All right, that's time. Thanks, Dean.
Thank you.
Welcome to Team Idol's presentation, and this is our team. Our team instructors are Michael and Shirley. Our clients are Potrino Lab that operates out of Mount Sinai Hospital. Potrino Lab is an ability research center that works with quadriplegic patients. The best way for quadriplegic patients to use a computer is through an eye tracker, but the normal computer interfaces are not eye tracker friendly, which makes it very difficult to use the eye tracker and also very frustrating. The current eye trackers are difficult to use, they are non-engaging and tiring, which makes the people not want to interact with the eye tracking interface. So in order to familiarize the patients with the eye tracking technology, our clients want us to create a fun and engaging game using an eye tracker and the click mechanic. Our demographic is 15 years older people who are neurologically injured, and now I'll invite Ryan to talk about our design pillars.
Thank you, Anjali. So we have three main design pillars: high engagement for guests, simple to pick up but hard to master, and provides analytics to researchers. So first off, we want to have generally good design principles. We want to pay special attention to this removes action-interaction dissonance, particularly with the way that gaze interacts with interaction and computer input. We also want to think about simple to pick up and hard to master, so thinking about low barriers of entry, but also designing objectives for mastery and encouraging replayability so we get continued engagement over multiple playthroughs. Finally, we want to think about providing analytics to researchers. Because both our clients are from research labs, they're interested in raw data and usage habits. By going back and forth, we're able to identify helpful constraints to develop our game around, such as metrics, usage habits, and moments of data collection. This brings us to our deliverables. Our metrics matrix, of course, our client requirements are most important, but also we want to focus on prototyping, playtesting, and gameplay/interactivity. We've had over 15 prototypes, over 80 playtests, which brings us to a very engaging game. And this game will be on the PC, and we'll use just the Topi eye tracker, as well as an agnostic click input. To show off the game, I'll hand it to Leo.
Thank you, Ryan. So let's talk about the gameplay. There are two modes in this game, a campaign mode and an arcade mode. We're going to show you a short demo of the intro cutscene and the campaign mode. So the cutscenes are edited version, but it still shows you the story and the relationship between the player and the enemy spaceships. There are 5 levels in the campaign mode. Starts really simple and gets harder over levels.
Where's the target? Searching. This is a good opportunity. I presume the ship has the new gazing maneuver system? Yes, sir. In addition, by gazing at a target, will accelerate drastically. Target close. Momentum. Bullhorns ready. Killer will flow successfully.
And here's a rewarding outro cutscene. Okay, so as we can tell from the demo, the campaign mode is an important introduction to our fantasy and mechanic, like gaze, chase, and fling. It introduces the shooting minigame, which provides the necessary analytics requested by our clients. However, according to the playtest feedback, we have an issue of player intent mismatch. That is, players like to fling more than chasing. So that they might look for asteroids and to fling them away, which is meaningless in the game. This kind of mismatch made it hard to design a meaningful level. Also, it's hard to tune the eye tracking movement. If you make it too fast, the enemy spaceship will get out of the sight frequently. It's an distraction. If you make it simple, it's easy to get bored. The fun reduces quickly. Therefore, to address these issues, it leads us to the idea of the arcade mode, and Ray is going to talk about it.
Thanks, Leo. And to introduce you guys about the arcade mode, I would like to invite you guys to see a live demo that's going to be played by Ryan. And he's going to start the 4,000 scores, which is the midpoint of the journey. And as we can see, this is a kind of endless running game that the players keep flying into things. And everything is going to be generated in 9 fixed positions. We're calling 9 tracks. And whatever item you're looking at, you can just move to that track. And you can fly through the stars to collect the scores, and you can fly through this green mist to get a hill. But also, there are dangerous stuff like these missiles that you have to dodge. Otherwise, you get hit, and they lost 1 life out of 3. And also, there are enemies. These enemy ships, if you click to fling them away, you get a scores like 50, but if you failed, still they're going to cost you lives. So after that training sequence. Now we're getting to the randomly generated sequence. And Ryan is just trying to get as much scores as possible in the journey. And of course, like that, sometimes he can hit an asteroid to hit an enemy before that, behind that, to get a bonus score, like 200. And during the whole journey, he's just going to try to survive as long as possible and try to get the most possible scores to keep his real-time strategies. And you've tried enough, right? It's time to die. Oops. And that's the end of his round of play. Thanks, Ryan. And for the arcade mode, what's good about this is now we have very accurate positions of everything, including item generated and also the player's position. So now the players are very clear about like what they're aiming at, when to flick, and how to dodge. And also we make the flinging a very appealing verb in the game, very rewarding. And also players can develop a real-time strategy, as I mentioned before, to it. Like here we can see the gaze is ready for an asteroid specifically, which has an enemy behind it. So that is when the player is trying to get a 200 scores bonus, and this beautiful firework. And then we got level designs to enforce the masteries that we want to the players. We're gonna start with teaching them flinging these single asteroids to get the sense of that time window to click to fling, and then these single stars to learn about looking at certain items to navigate. Then we have a bunch of these scripted sequences to teach them the new mechanics when introduced in the game. Like the first example, they're gonna have to hit one of the enemies, and then they're gonna know what will happen when they encounter certain things. Same thing applies to the other examples, like all asteroids and then enemies after that, hit an enemy to an enemy for 400 scores, and so on. And also, we're gonna reinforce a sense of growth to the players. So we have these waypoints, these milestones as new on boards, showing up at certain points of the journey when they're getting a certain amount of scores. And this is to tell them you're getting better and better and going further and further in this journey. And later, we're gonna also to reinforce the replayability in the game. So we have the score details when you end the game, and also a local leaderboard that stores the best 10 scores, and also a progression bar telling you how many elements has been unlocked and how many elements has been unlocked. And this is another example, which when the player gets the best scores in the record, and there's a icon of the new record pop up. And lastly, I'm gonna mention the shooting missile game is kind of different in the arcade mode, that when you shoot faster to a missile, you can get higher scores. Like the example here, if you shoot very fast, it's 100, otherwise it's only 50. And we believe that this mechanic can extract better reaction time data out of the players. And to mention more about this analytic minigame, I'm gonna pass it to Bob.
Thanks, Ray. So, as we said before, there were certain milestones that people reach to. And every now and then, there's a milestone that's the analytics minigame. And this is what allows the researchers to have a snapshot of the guest's ability as they progress through the game. But it also gives the researchers the ideal analytics that they want, and it answers the questions that they are interested in. But since it's only at a certain time and space, it allows the guests to not always be monitored and evaluated. So let's go through an example of how this minigame would look. So right now, we're going to enter the minigame, and we're going to see 8 missiles appear in 4 distinct locations. 1, 2, 3, 4, and it's just going to appear at the same place again. Right? So the questions we're asking is, how fast are they shooting them? How close are they to the missile? And how repeatable are these attempts? So if people remember, we had a missiles up in the center here and one at the corner. And we're trying to see time to reach and time to shoot. So the time to reach to the missile that isn't at the center it's 3 times more than those are at the center. And if we look at the accuracy for those levels, the smaller the circle, the more accurate they are. So the one at the center is much smaller than this one. And since there was 2 attempts, there's a standard deviation between them as well. So this one is 3 times higher than this one. So repeatable attempts come here. But this is why we're really enforcing the fact that we want people to explore the edge so they get better. And as people try this more, there's multiple evaluation points as people try it out. And as you can see here, on the first attempt, these circles are way big. But by the 4th attempt, they become smaller, a bit more consistent. And now I'm going to pass it to Ariana for art.
Thanks, Bob. So for the art, we've made lots of iterations since our house. First, for the spaceship, We've developed our spaceship from the concept art to the rough model and high poly models. And we also taking lots of feedback to make them more realistic, distinctive, and interesting to look at. And we also made iterations for our game environment and UIs so that we can improve the visual clarity and make the gameplay rewarding and juicy. So here's a comparison between our first and final version of the game view. There is a big difference, and we would like to break down to 3 major parts: the hue, saturation, and lightness. First, for the hue, we've shifted the color of the enemy slightly from the pinky red to orange red, and we also shift the color of the skybox from a purplish blue to a greeny blue, so that we end up having more contrast in those major colors as they are further apart on the color wheel. And next, we also desaturate the color of the non-major objects and keep the saturation and keep the high saturation of the major objects. And finally, we tone down the brightness of the skybox as well as to light up the objects in the scene so that the game objects have more contrast and they are like separated from the background. And next, for the UI, we want to make our UI simple, clean, intuitive, and center-framed, so that it's convenient for eye tracker gaze use. And our next goal is to make our gameplay rewarding and juicy. For the art, lots of VFX and props are added to enrich the visual pleasure. And other than art, we also work on the game design to ensure that simple user inputs grants huge positive feedback, as well as the sound design to be responsive and rewarding, so that we end up make our game can bring the game itself to life, encouraging replayability and engaging the guest. And next, Ryan will talk about the accessibility.
Thank you, Ariana. Oh, sorry. So beyond just the design pillars, we want to make sure that this game is really useful in all sorts of situations and use cases. So we went back and forth with our clients yet again, and we went through like a bunch of features that they would want and features that we would find helpful for them to actually make this applicable in as many circumstances as possible. So I'll let you guys look at the short list for a little bit. But again, we also want to ask, well, how was this received by our clients? And so let's hear it from one of our clients themselves.
The analytics provided are as detailed as we required. Having raw data allows us to tabulate information across multiple sessions of gameplay, which we expect to have because the game has been designed to be fun and engaging in a way for our users to really appreciate versus the boring testing we normally do.
Thank you, Dev. So where do we go from here? Our other client, Dr. Adam Fry, says this: we hope to use this game to introduce quadriplegic patients to assistive technologies, including eye tracking itself and brain-computer interfaces that might benefit from the addition of eye tracking while learning to use the technology. Our expectation is that this fun game will increase patient engagement, which is so important to achieving successful outcomes. In short, they would like to use this application to gather data in their labs, but also to put on patients' personal devices such that they can use this as a form of actual entertainment than just data collection. Additionally, they would like to augment it with external hardware to make it a truly accessible game and experience. We are Team Ideal, and we are accepting questions. Thank you.
Yes?
Was it play tested with actual patients or?
Yes, we gave the.
Did they do that or did they do that?
They performed the test themselves. So they got a transcript from different people who have been who have different sorts of disabilities.
Yes, and their commentary was basically the same as the playtesters that we had here. They would, well, in the first playtest, they would be annoyed about the asteroids, not knowing when to click them, not having a score to be needed, so it wasn't quite different.
Thank you.
Catherine?
Do you happen to know if the playtesters at Mount Sinai were already familiar with using eye gaze to navigate a computer, or if they were new to it?
We are not within,
sure.
yeah. But one thing that we have found was, again, eye tracker is a technology that is new to most people. So the thing that we did find that able-bodied people as well as people with disabilities were able to pick it up just as easily.
Yeah, a key, yes. Mo?
Yeah, in terms of that potential to mastery, can your player testers or yourselves get really good at it, and what was that path like?
So the answer is the top high scorers for the game are on this row right here. There's also been, as you've seen the data that we have, all of us are improved from the data that we have. The data that we showed is actually an outsider, not on this team. If people are interested, it's Mike's data. But no, there's extreme improvement, no frustrations on our side. And it could be from the minigame, or it could be from the game itself as a whole. Correlation is not causation. Any other questions?
Time for one more. Bob's not in the audience.
I know.
All right, thanks, team.
Thank you.
Wakes me up.
Oh, I believe that. I totally believe that.
That was a surprise reveal that I didn't know I needed. I was surprised that I got better.
You just feel like
I knew I was better behind but I didn't know where I was looking at the tolerance. There, I got
how many hours or minutes did you play?
I played 3 hours.
Okay, that's a chunk.
3 hours approximately.
Yeah.
Trying to get to 20,000, 18,000. I believe the building for the semester until I get 20,000. I might not make it. Why are you doing it?
Like I went down deep, but you see it's like time. And again, it tells you I really don't like it.
All right, hello everyone.
Especially because it's not spent. It's focused.
Hi everyone. We are 404 Productions. This is our team, and these are our instructors. So we are making an interactive web-based game for PicoCTF. PicoCTF is a cybersecurity competition held by Carnegie Mellon University's SciLab. They hold it every year, and is a cybersecurity competition. So people will be tackling questions to answer using cybersecurity concepts to try to progress and earn points. This is example. This is a 2019 version of the game, and is roughly what our game will look like. It'll be web-based, and it'll be inside their platform. Our target demographic is high school students who have little to no cybersecurity knowledge, which is why will play this game and hopefully learn something. So our goals are to convey cybersecurity concepts to these people, and to encourage players to continue the competition to try and learn on their own, and try to tackle these questions, which would be hard for them, and try to complete them. Our game consists of 4 different mini-games, which each tackle different cybersecurity concepts, and 1 game wrapper to link everything together and to bring it back to the PicoCTF competition. Minigame 1 touches on ASCII code. You guys already saw this at the softs, so here is just a brief recap. It is like an escape room minigame, and they'll be given different codes, which are written in ASCII. So the players will use ASCII to decode these messages, which will help them progress through the minigame. And through testing, we realized that players didn't really know where to head from different things because they were in a big room. So we've added more feedback. We added motion. So for example, here you can see the book, which with all the ASCII codes will go up to the corner. And so it guides the player to know what they need to do and how they can get information. Minigame 2 touches on hashing and command line interface. And we have a live demo for that. So this minigame, we have backup. All right, so while we're getting this set up, Josh will talk about mini game 3.
All right. Sorry, guys.
Let's continue with the presentation first. So in minigame 3, we are introducing the idea of assignment, which in programming is the equal sign, and the comparator which is the double equal sign. This is where the live demo goes. Sorry, you have to wait a bit. So let's actually talk about how we iterated, and then we started out with this very rough concept in the Google slide. That's our prototype, and then iterated, and then arrived finally at the final product. So basically, as you can see here, we, during a lot of our play tests, we noticed that our game increasingly harder. So a lot of players are kind of like suffering till the end of the game. So they want to know like how far their suffering is going to end. So we basically at the very top like a stage indicator indicating where they're at the mini games, the stages in the mini game, and then we also kind of removed, even though like this is a circuit fixing game involving voltages, calculation stuff, we removed the voltage at the very end with the target 6 voltage from there to here. Because during playtesting, we noticed that a lot of the cases, the voltage doesn't help the player. It kind of confuses them. It doesn't add anything to the gameplay. And also, finally, we added this highlight to all the tiles where they can put the tiles, the component on the left, just to help them ease into a game a bit more. And next, let's actually talk about the concept of minigame 4.
Well, life is full of surprise. Minigame 4. I'm not sure how should we introduce this because this should be a live demo. We're gonna show you guys a whole demo of all our minigames, so don't worry, we made a great product, so we're gonna explain everything, all your concerns. So in this game, it's actually a potion making game, just like a spoiler. So one thing we did is we put something like this, like a highlight to specify where players should put a correct block. If you don't understand what that means, we're gonna show you guys later. And we will have a notification of running loops. So how the game works is the player will put blocks and it's gonna run each blocks, there will be loop. And this, you guys will see later, is that we show them the count of the current loop so they don't get lost during the running of the game. And the last thing is we will have a speed up button that the player can use to speed up animation if they feel bored. And let's do demo, should we?
Sounds good. All right, so this is our game. And you can see that we started it up, it's working. We have music, but it's not a main concern of ours, so I'm gonna mute that so you guys can listen to us as we talk over our game. So.
Well, usually we only show 4 mini games, but now we show the whole thing, so you guys earned it.
So this is a bit of an intro to like get you into the mood for the game and help you get involved in the setting. And then after that, we're going to bring you to a overworld map where you can pick and choose different games that you want to play. So we'll go back to the first game, or minigame 2. Minigame 1 we showed during soft, so this will be the first one that we'll demo live here. This is called Feeding Creatures, and we're covering command line interface and hashing. So down here, or the overall premise is that these are creatures who are asking for cookies. And so you'll need to make cookies for them so that they can eat them and be happy. And to do that, you have our version of a command line interface down here. So you have different commands, prepare, bake, and transfer. And each command has different arguments. So for prepare, you can choose different ingredients to put inside. To execute it, you cast a spell, and then the command is executed. So all of these commands and casting spell will execute, and then we'll make cookies here in this cookie making machine. And this is our version of hashing. So different ingredients will go into this machine, and then out will come a cookie. And like hashing, you don't really know what comes out at the start, so you need to experiment. But up here in the top left-hand corner, you can see that the recipes which you've done previously and what will come out. And you can see that just like hashing, the order of ingredients matters. So here I put an olive and a worm, and it came out with a different cookie. Then I put in a worm followed by an olive. So next, I'll pass it to Josh. We'll talk about mini game 3.
Yes. Minigame 3, we are calling it Connecting Magic. It's basically you fixing circuit by putting into the circuit components. And before every minigame, we have a tutorial section telling the players their basic verbs and stuff. All right, so let's jump right into it. So basically, you can see here on the left, we have assigned. So these are kind of like the keys that you assign here to activate the circuit. And after that, you have to click the component on the left and drag it or put it on the circuit to kind of let the electricity flow. And now I'm just quickly going to finish this level. So we're basically teaching the players the basic mechanics in the first 2 levels. And here you can see, we're introducing the comparator sign, the double equal sign here. And I'm not going to show you how you should solve this level. I will leave it to you. And actually in the minigame, we're going to talk about the minigame 3. Our final minigame. So.
And he didn't solve that because he does not know how to solve it. Yeah, so let's go to the game that I just talked about. This is the potion game. Also, we have the cool loading screen. Google is your friend. Yeah, so in this game, the player needs to make a potion according to the recipe we listed here. And in this making sheet, so let's see, the first action is amber powder. So we find one here, let's click on this, see the highlight I just mentioned. So the player knows that they're going to put it here. And the next thing they may notice is that there's an actual translation here to tell them what they did is kind of correct because it matched here. So next thing is the liquid, and then mix all. And then, it comes the problem. It needs another liquid, but I don't have any more. So they need to rely on the loop here. They put on it here. Okay, here comes the errors. It tells you the left bracket in line 2 is missing the right bracket. We mimic it so that it's more like a real programming error. So they need to solve this by placing the correct right bracket. And then now it works. And you see the real-time compiler here translate the loop into the actual duplicate of these 2 lines. So it matched the recipe. So the last thing is this 2, and then that works. And you may also notice that these 2 lines are indented automatically. We put it so that the player may notice how indentation works on the hierarchy, but they do not need to use it to finish the game because it's something extra for them. So we only tell them here, and then in another section, we're going to have a recap for this. So let's cast the spell. And it's going to run it each block, and you see this is what I mentioned before. It's going to tell you this is the second time of the loop. And then it's going to next, and next. Yeah, we don't have enough time. I want to show you guys more, but let's exit here.
Hello, so next I'm going to talk about how our game fulfills our goals.
So as you might have remembered from our previous presentation, our goals are to convey the concept and in cybersecurity, and also encourage players in diving more in this field. So we have different sections in our game, including 4 mini-games and game wrappers such as the office hours and the bulletin board. They all form as a whole ecosystem which connects the gameplay to our PicoCTF competition. In office hour, each time players complete a mini-game, they can come here and learn more about the cybersecurity concepts ties tightly into the game they just played. And in this bulletin board, players can get access to the real PicoCTF questions, and every time they learn from the game and the office hour, they can come here and try out some real challenges. And also, we have a point system to encourage the players and give them a way to measure their performance. So many of our games have multiple levels and can be difficult and very replayable. So players can always aim for the better scores and have fun with it. Also, we familiarize players with the terminology with our interface design and notations. And it's not just about the terms, but also about the logics. As you can see, all of our mini-games are based on the concepts of cybersecurity. So players can understand it through understanding the game rules. And in their future learning, they will be able to recognize and associate it with the experience. We also take full advantage of our loading screens to ease out the anxiety of waiting and provide players with more information and tips. And next, I'm going to pass to Giselle for Tech Club.
Thank you. So the first client requirement is randomization. So we randomize the book, the code, and the cookies to serve. And we made game pools for the circuit game and the potion game, so it's randomized. And the second requirement is to support the low specification devices. So we made the game extremely small. It's 62 megabytes. And it's a 2D game, so it doesn't require much computing power. And we tested on the least powerful devices we can get. So we tested on the slowest Chromebook from DTC, and we tested on the 10-year-old MacBook, and it works well. And we were able to run the game even on mobile devices, so we hope we can cover most of the students' laptops. And we went to the Cornell High School, and we observed that students didn't use a mouse. And they used the trackpad to click, drag, and move a cursor. So as you know, dragging using the trackpad is really painful, so that's the reason why we made a click as the main input. And and the second thing is it auto saves and auto loads, so it is connected to the client server. So when I play the second time, it doesn't start from the intro. We can skip all the things, and the data is loaded from the client server. So we got a lot of help. We appreciate it. Thank you for listening. We are for productions. Now we are open to questions.
Yes, sorry, you might have covered this, but how long do you expect a player to interact with?
Thank you for the question. So the question is basically how long do we expect players to interact with the game? So over the course of playtesting, we've seen that it can range from different players to players, and also some of the games that we have, there are advanced levels. For example, in our portion making game, there are 4 different levels of difficulty stages, and in our circuit making game, there are 5 different difficulty stages, so it depends on how much a player wants to try and tackle the harder questions. But overall, if they play through the entirety of the game, it could take roughly maybe an hour. And the competition itself will be, I think, a month. So yeah, so they can try a bit, and then when they can try out some PicoCTF questions, and then they can come back to the game maybe on a different day maybe, and then continue playing more and try different topics.
For me, in a Pico CTF project, this was the most effective art. How did you make decisions about the art and the look of it?
So the question was, how did we make decisions about the art? I'll leave it to Tianning, who is our UX and artist.
Yes, so we started with an idea to wrap this game as a magical world, so to let our target audience be more interested in the cybersecurity concepts. And so we formed this world by starting with the concept as a whole and make the interface consistent throughout the experience. And also we create some such as the magical creatures and things like that we have seen, which all tags back into the thing.
Thank you.
Yes, please.
Do you know if players have difficulty making the jump from your command line interface to actually typing in the command line interface, or is your labeling of things pretty straightforward?
So the question is how we bridge the experience in the game to a real life situation. Okay, so we basically have a section called office hours. So we have screenshots of all the interface in the game, kind of in that office hour, and then we introduce them and kind of bridges the gap for them by explaining what this stands for in real life. And also the purpose of the game is not to teach them how to type exactly as a programmer, but then introduce them to the ideas. So yeah, that's how we do it.
Yes. Is the main purpose to introduce people to computer science or to get them better?
It is to introduce, not to get them better. Oh yes, please.
Okay, so this is a competition, right? The people CTF or just a conference?
So we have mini competition. This is for mini competition. So they are practicing how to solve the security problems, and they are going to have the real competition after this mini competition.
Okay, so how's the scoring system work? It's basically how many they solve at the end, or is there a correction system somehow?
So the question is about the scoring system. So to recap, our game is actually going to host in Pico CTF mini competition website. So in the game, they can solve different levels of game, and each level is going to give them score, of course. And then when they solve those, they can also, through the link inside our game, they can jump right to the Pico CTF mini competition questions. And when they solve those scores is going to add it back to the game. So it's in summarize, the score composed of 3 parts: the mini games, the real Pico CTF competitions, and also we give them extra score for visiting the office hour to learn some stuff.
Thank you. All right, that's time. Thank you. Okay, congratulations to the team today, to all the teams. You did your final presentation. All right,